All right. So let's finish with numbers 7, and then we'll talk about some practice. So these are the graphs for number 7. So 7C. So I'm going to start with the parent function. I'm just going to write down -2, -1, 0, 1, and 2. We're just going to transform that. So absolute value of -2 is 2. Absolute value of 1 is 1. -1 is 1, 0, 1, and 2. So now we're going to reflect it. So that means all of these change signs. So this is going to be -1. This is going to be -2, 0, 1. Sorry, -1 and -2. And then this -1 moves it to the right. So if I move something to the right, I'm changing the x value. So instead of x being -2, if I move to the right, this becomes -1. This becomes 0. This becomes 1. This becomes 2. And this becomes 3. So I moved every point to the right. And then this +3 is the movement on the outside, vertical. That's my y. +3, +3, +3, +3, +3. So this says when x is -1, my output is +1. When x is 0, my output is 2. When x is 1, my output is 3. When x is 2, my output is 2. And when x is 3, my output is 1. So when x is -1, my output is 1. When x is 0, my output is 2. When x is +1, my output is 3. When x is +2, my output is 2. When x is +3, my output is 1. So as you can see, we have reflected this over the x-axis. So the vertice really started here and went up this way, parent function. We moved the vertice to the right 1. We reflected it, and then we moved that up 3. That's really what happened, okay? So domain again, all real numbers. When I look at my range, the highest my graph goes is 3. So all of my y values are now less than or equal to 3. All of my y values are now less than or equal to 3. So for this next one, again, I'm going to start with the parent function, just so you can see what's happening. So I just always try to use the same points. Makes it easy. Remember, the absolute value of any negative number is positive. Okay. So let's talk about the transformation that's taking place here. This is a compression. It means that you're going to take all of your outputs and multiply it by 1/3. So you're making the graph shrink or vertically compress. You're going to make it like shorter and squattier. This -2 on the inside, remember that moves me 2 units to the right. +1 moves me up vertically. So the first thing that we want to do is compress it. Let's compress. So when x is -2, my output is typically 2. But 2 times 1/3 is 2/3. 1 times 1/3 is 1/3. 0 times 1/3 is 0. 1/3 and 2/3. I think I wrote 1/2 there. Sorry. Okay. So now this movement makes me move 2 units to the right. When I move to the right, I'm changing my x value. So instead of x being -2, now it is 0. Instead of x being -1, now it's +1 because I'm taking -1 and I'm moving it 2 units to the right. Taking the number 2 and moving it 2 units to the right. So that would become a 4 when x is 2, when x is 2, I add 2 to that, now it becomes a 4. 1 plus 2 is 3, and 0 plus 2 is 2. So that's what moving 2 units to the right does. So let's go ahead and put a -3 up here, just so we have a negative value. So 1/3 of 3 is a +1. And I'll add a positive 3 down here at the bottom so I still get a 1. And then when I think of negative 3 plus 2, this is going to give me when x is negative 1 now. And positive 3, when I move it 2 units to the right, that's going to be a graph at 5. And then lastly, I'm going to add 1 to all of these. So 1 plus 1 is 2. 2/3 plus 1 is 1 2/3, or 5/3. 1 1/3. 0 plus 1 is 1. 1/3 plus 1 is 1 1/3. 2/3 plus 1 is 1 2/3. 1 plus 1 is 2. So let's graph this just so you can see what's happening. So when x is negative 1, my output is at 2. When x is 0, my output is at 1 2/3. So that's almost to the 2. When x is at 1, my output is 1 1/3. So that's right above the 1. When x is 2, my output is 1. When x is 3, my output is 1 1/3. When x is 4, my output is 1 2/3. And when x is 5, my output is 2. So this absolute value graph really looks like this. So something that you can do, I'm going to scroll down for a second just so you can see. I'm going to use numbers that are divisible by 3. So if I were to use negative 9, negative 6, negative 3, this is a trick that we used to talk about in math too, right? If you're going to multiply something by a third and you want to graph whole numbers, well, then just choose numbers that are divisible by 3, right? So if I were to use these numbers as the absolute value function, the square or the absolute value of 9 is positive 9. So all of these numbers are going to be positive. So if I were to take that transformation, the first one says that I multiply all of my outputs by 1/3. 1/3 of 9 is 3. 1/3 of 6 is 2. 1/3 of 3 is 1. 1/3 of 0 is 0. 1/3 of 3 is 1. 1/3 of 6 is 2. And 1/3 of 9 is 3. Then I have to move 2 units to the right. 2 units to the right. So instead of x being negative 9 plus 2 is negative 7. Negative 6 plus 2 is negative 4. Negative 3 plus 2 is negative 1. 0 plus 2 is 2. 3 plus 2 is 5. 6 plus 2 is 8. And 9 plus 2 is 11. So I might not be able to graph that one. And then lastly, we add 1 to each one of our outputs. So 3 plus 1, all of these get a 1 added to them. So when x is negative 7, so I'm going to regraph this just so you can see it. When x is negative 7, y is 4, because 3 plus 1 is 4. So when x is negative 7, 1, 2, 3, 4. I'll give you a bit better picture. When x is negative 4, y is 3. When x is negative 4, y is 3. When x is negative 1, y is 2. When x is negative 1, y is 2. When x is 2, y is 1. When x is 2, y is 1. When x is 5, y is 2. So here you can see that's where the change happens. This is my vertex right there. Right here. This is the vertex. And when x is 8, y is 3. So when x is 8, y is 3. And I'm off my graph. But this is what that looks like. That's what that looks like. So I should have done that originally. If you have a multiplier of a fraction out front, go ahead and make sure you choose numbers that are multiples of that or divisible by that, okay? All right, so let's look at these E and F. These are piecewise functions. So piecewise, oh, hang on a second. Sorry, I forgot about the domain, all real numbers. Range, the smallest number here is positive 1. So y is greater than or equal to 1. Okay, so piecewise functions. A piecewise function means that you're graphing 2 or 3 different functions on the same graph based off of these rules. So for all values of x that are less than 0, so values of x that are less than 0, I'm going to use 0, -1, -2, and -3. For all values of x that are less than 0, y is going to equal 3. Y is going to equal 3. Well, that's just this horizontal line, right? That's the line y equals 3 right here, this horizontal line. Notice that x has to be less than 0. So when that happens, right, think about your inequalities. You're going to put an open circle where x is 0. You're going to put an open circle right there at the 3, and then everything else is included. So the second function that we're graphing is for all values of x that are greater than or equal to 0. Let's see, that's 0, 1, 2, and 3. We're going to square it. 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. So it's going to look like the right half of a parabola. So 0, this point, it's included because of the inequality greater than or equal to. So when x is 0, y is 0, x is 1, y is 1, x is 2, y is 4, x is 3, y is 9. So this graph looks like this. I'm going to put an arrow going to the left for all numbers that are less than 0 and an arrow pointing up for all numbers that are greater than. And that's what that looks like. So your domain, still all real numbers, right? Still all real numbers. Even though 0 is not included in the top, it is included in the bottom. So it's still all real numbers. But the range, your range, well, the smallest y value you have is all of the y values that are greater than or equal to 0. All y values that are greater than or equal to 0. All right, last one. So if this is, the rule is for all x values that are less than 1. So I always start with that number. 1, I'm going to use 0, -1, and -2. And I'm going to use this rule. The function is 3x minus 1. So when x is 1, 3 times 1 is 3, minus 1 is 2. When x is 0, 3 times 0 is 0, minus 1 is -1. When x is -1, -1 times 3 is -3, minus 1 is -4. Do you guys see that this has a slope of 3? So the difference between all of these is 3, and I'm counting backwards. So this is really going to be -7. So let's plot these points. When x is -2, y is -7. When x is -1, y is -4. When x is 0, y is -1. And when x is 1, y is +2, but that's not included. So it's going to get an open circle there. I'm going to connect these points with a line like that. Now we're going to do the second rule, and this is for all values of x that are greater than or equal to 2. So 2, 3, 4, and I'm going to throw a 6 in there just so the rule is half of x. So half of 2 is 1. Half of 3 is 3 halves or 1.5. Half of 4 is 2, and half of 6 is 3. So the the 2 is included in this. So when x is 2, y is 1. When x is 3, y is 1.5. When x is 4, y is 2. And when x is 6, y is 3. So this is going to be a line that has a slope of 1/2. So let's talk about our domain. We have a gap in our domain, right? So our domain is all of the x values that are less than 1 and all of the x values that are greater than or equal to 2. So we want to write this as a compound. Well, we could write it as a union. I don't know if you guys are doing set notation or not. I don't know if you guys are doing the union. So when we think about interval notation, you could write it as, let's see, all the numbers that are less than 1, that's going to be negative infinity to 1, and 1's not included, so it gets a parenthesis. Negative infinity, we don't know what that number is, so it gets a parenthesis. And then it includes all of the numbers that are 2 or greater. So 2 is included in that. And then greater than positive infinity. But I don't know if you guys are writing it like that or writing it like this. So either one. That's your domain, sorry. So your range, you notice that this goes all the way down to negative infinity. There's no gap here, and it goes all the way to positive infinity. So this range is all real numbers. All real numbers. Okay. So I have created just a real quick worksheet. So remember that if you have a plus or minus inside the function, that's going to move. Plus moves you to the left. Minus moves you to the right. So you can try and graph this one. If you look at this example, we are not doing anything inside the function, but this plus on the outside means that I'm going to move up 3 along. So my vertex is moved up 3, and this is reflected. So I reflect it, and then I move it up 3. So I drag the vertex, and I go up 1, 2, 3. So it's just this. Okay. When you look at this next one, this is right 1 unit and up 4. This is left 1 unit and up 2. This is going to be reflect over the X. So it's going to open downwards, right? So it's going to be reflected. It's going to move to the left 2, and then it's going to go down 2. So when I reflect it, it looks like this. When I move it to the left 2, it looks like this. And then when I take my vertice and I move it down 2, my vertice is now right here. And it looks like this. And I'm going to highlight in that yellow so you can see it. Okay. This has a reflect, has a vertical stretch. This has a lot. It has a movement of right 2 units, and it has a movement of up 2. Okay, so let's start with the reflect and the stretch. So 0, 0, 1, and -1 are now going to be multiplied by 2, right? So that stretches it to 2, and then 2, an output of 2 is really 2. Multiply it by 2 is going to give me an output of 4. So we've taken care of the reflect and the stretch. That's the reflect and the stretch. And then I have to move it 2 units to the right. So my vertice gets moved over 2 units to the right and up 2. 2 units to the right and up 2. So you really could take every point and move it 2 units to the right, up 2, 2 units to the right, 1, 2, up 2, 2 units to the right, up 2, 2 units to the right, up 2. So that's what this looks like. Your last one, it has a stretch on the inside, and that's something that we really haven't talked about. So let's write it out. So -3, -2, -1, 0, 1, and 2. So the absolute value of -3. Well, let's just plug it in. Let's just plug it in. So -3 times 3 is -9, plus 4 is -5, and the absolute value of that is a +5. -2 times 3 is -6, plus 4 is -2, and the absolute value of -2 is +2. 3 times -1 is -3, plus 4 is 1, and the absolute value of 1 is 1. 3 times 0 is 0, so this is going to give me 4. 3 times 1 is 3, plus 4 is 7. 3 times 2 is 6, plus 4 is 10. We need to go, are we getting smaller and then larger again? Yeah, we already have a vertex. So when x is -3, y is 5. When x is -2, y is 2. When x is -1, y is 1. What am I doing wrong here? -3, +5, -2, +2. negative 3 is, I've got something wrong and I need to figure out what that is. 0. Oh, it's my vertex. That's 0 is 4. 1 is 7. I go off the graph. So I have what happens when X is, I've made a math boo-boo here and I'm not sure what it is. So I need to look at this. I'm going to just try it one more time. Sorry, that's what if I make a mistake, I just do it over again because I don't know where my error is. Okay, so negative 9 plus 4 is negative 5, positive 5, 2, 1. So I have to have a vertex right here. There's a vertice somewhere in here that I'm not seeing. When X is 0, I'm at 4. And when X is 1, I'm at 7. So I'm going to go off my graph. So I'm guessing that my vertice is about right here. So like 2 and 1/3. Let's see, negative 2 and 1/3 is negative 7/3. So when X is negative 7/3, that's going to be negative 7. That'll be right here, negative 7/3. It's going to give me negative 7 plus 3 is 3. What about negative 5/3? X is negative 5/3. That's 1 and 2/3. It's going to be negative 5 and 1. Yeah, I have a vertice that's going to be right in between negative 5/3 and negative 4/3. That's why that looks weird, but that's what that's going to look like. Sorry about that. Okay. So anyway, that's your review, your practice, and we'll get another video for